Alright, so we are on triangle congruence still. This is day 2. Like my little Yoda, little joke there for you. If you don't watch Star Wars and you don't know who Yoda is, you'd have no idea what that meant. Anyway, so beyond that, let's move on. So learning goals for this. I can determine the value of a variable that would maintain the congruence of triangles, and I can find the lengths of given sides that would maintain congruence of figures. Some vocabulary for you. We've got quite a bit in this, so please make sure, I'm not saying you have to write it all down, but make sure that you at least understand what each of these are. Legs of a triangle, those are two sides of a triangle that form the vertex angle of the triangle, which we'll get into in a minute. The base of a triangle is the side of the triangle that's opposite the vertex. So if I have an image here, I'm going to go ahead and label these to make this easier. So the legs of a triangle would be, and you probably can't see that because it's probably really small, so let's widen up the triangle a little. So that would be a leg, that would be a leg, this would be the base. The vertex of a triangle, which is right there, and it refers to the angle, could be any angle of a triangle really, but it usually refers to the angle that is the perceived top of the triangle. So depending on the diagram or image that you have, it's what looks like the top. But keep in mind, it doesn't have to be. Base angles of a triangle, so this would be your base angles here. Base angles, base angles. That's the remaining angles that are not the vertex. And then an isosceles triangle is a triangle whose legs and whose base angles are congruent. So if I have a triangle that would, and it's isosceles, these two would be congruent and these two would be congruent. So the legs of the triangle and the two base angles would both be congruent. Alright, so determine the value of x that would maintain congruence of the triangles. This can be tricky because this one's really easy to mess up if you don't remember. And notice that this is an isosceles triangle because these two legs are congruent, which means remember that the two base angles are congruent. So you need to kind of get from that if this one's 41 degrees, this one also has to be 41 degrees. And then we have this vertex angle of the congruent triangle that is 3x plus 2 degrees. So we're told that these are congruent, so these angles are 41 degrees each. And we're going to set this up. So this is the total degrees in a triangle. So that's however many degrees are in the triangle. And they have to add up to 180. Now I know I have two angles that are 41 degrees each, which is where I got that. And then I know I have a vertex angle that is 3x plus 2 degrees. So when I add all this up, it has to equal 180. So first I'm going to multiply the 2 and the 41 together to get 82. And then I'm going to drop the parentheses because I don't need them anymore because now all we have is addition over here. Remember, do not multiply 82 by any of this. You're going to get really screwy answers if you do. So because of this plus sign, do not try and distribute over the parentheses with the 82. Now I'm going to combine my like terms, the plus 2 and the 82, to get 180 equals 84 plus 3x. Now this is much more manageable, so all I have to do is subtract 84 from both sides, which would give me 3x equals 96. Divide both sides by 3, which gives me 32 for x. Now, that's the value of x. If I wanted to know the angle measure, I would go ahead and figure out and plug that in for the vertex angle to give me an angle measure of 98 degrees. But all they asked was to determine the value of x, so that would be your answer right there. I'm just going on to show you that you can find this, which will help you see if you're right. Because if I go ahead and plug that in and get this 98 degrees and I added 41 plus 41, remember they have to add up to 180, which these do. So that's how I know I'm right. So if you need to know, just double check and go through it and do what I just did. Alright, so for the next example, we're given that segment AC and segment DF are corresponding sides of a figure. Find the lengths of the given sides so that that would maintain the congruence of the figures when AC is 11a plus 9 and DF is 9a plus 27. So it doesn't, what the figure is doesn't matter. We just know that AC and DF are the congruent sides, which means that they have to be equal. All right, if they're congruent, and they're corresponding, those sides have to be equal. So now we have an equation with variables on either side. Just do what we did last unit. Subtract 9a from both sides, so we're getting all of our variables on the right hand side. So basically what we're doing is we've got this line again, all right, which will give us 2a plus 9 equals 27, and then we would subtract 9, because remember we want to isolate the variable from both sides, because that gets rid of that, zeroes it out to give you 2a equals 18, and then finally you divide both sides by 2 to get e equals 9. Now, unlike the last problem, this problem asks us to find the lengths of the given side. So here we actually do have to go ahead and then take that 9, and you can plug it into either equation. If you got the answer right, you should get the same answer in both of them. So I chose the first one. 11 times 9 plus 9 is 108. 11 times 9 is 99, plus 9 is 108. Just for the sake of it, let's go ahead and plug this in over here. 9, and we'll plug it in for a, plus 27. Let's see what that equals. So that would be 81 plus 27, and it equals 108. So I know I'm right. And it just goes to show it doesn't matter which one you plug it into. All right, so that is it for this unit. We have one more target, 2 more days of it, and then we're done with the initial geometry unit. We do have more coming, but this was just the initial part. So as we get going on this last part, if you need any refreshers on the algebra stuff, or if you need some further explanations on the geometry terms or steps to do any of the problems that we've done, please come see me. Thank you.